Now we are discussing about voltage to current converter. Here you may have the interpretation like we are changing the voltage to current because it is converting voltage to current. But in the reality, the output current is directly proportional to input voltage. If we change the input voltage, accordingly there is a change in the output current. If we increase the input voltage, the output current also will be incremented. If we decrease the input voltage, the output current also will be decremented. This type of circuit we are building, it is called as voltage to current converter. In the voltage to current converter, we are mainly having two types. One is floating load voltage to current converter. Second one is ground load voltage to current converter. In the floating load voltage converter, the resistor we are using, or technically the load we are using, no end of the load is physically connected to the ground. You may ask the question, sir, but it is virtually grounded with the concept of the virtual ground, because we have grounded the non-inverting terminal, so obviously VA is becoming 0. Your point is right. Virtually this terminal is grounded, but physically we have not grounded. And one point you have to remember, the second terminal we are connecting to the output. So this type of connection is called as floating load V2I converter. And similarly, when we are operating the operational amplifier in the non-inverting mode, here the floating load will be like this. No ends, both ends are not physically connected to the ground. Now we have to check the relationship between the output current and the input voltage. We know because the op-amp is having very high input impedance, it does not allow any current from this terminal towards the op-amp. Whatever the current that is entering at the node A, the same current should leave from the node A. Therefore, I is equal to IL. Whereas I is nothing but V in minus 0. With the concept of the virtual ground, VA is 0. Therefore, V in minus 0 by R1. It is equal to 0 minus V naught by RL. And we know here, from this we can get the relationship between V in and V naught. But what is actually output current IL? This output current IL is nothing but same current I is entering through it. What is this I? I is nothing but V in by R1. I is nothing but V in by R1. V in minus 0 by R1. So this equation is representing that output current is directly proportional to the V in. So whatever the relation we obtained, we are once again trying to understand the relation. See, here I have taken the current I. I is nothing but V in minus 0 by R1. Why I am taking 0 means it is virtually grounded. Therefore, I is equal to V in by R1. But this I is equal to IL. Therefore, V in by R1 is equal to IL. Therefore, IL is directly proportional to V in. That means the output current is not depending upon the load resistor. Even though you change the load resistance from 1 kilo ohm to 2 kilo ohm to 1 mega ohm, output current is not being affected. Output current is depending on the input voltage V in. That's why we are calling this as a voltage to current converter. Similar concept we are trying to understand here. We know VA is equal to V in. How VA is equal to V in? Because it is the concept of the virtual ground. At the non-inverting terminal, node B, we have the voltage V in, same voltage will be observed at the inverting terminal, node A. The current entering at node A and the current leaving at node A both are equal. Therefore, I is equal to IL. Where I is equal to, we know I is equal to, here we want to get the relationship between I is equal to VA minus 0 by R1. But because through the concept of the virtual ground, VA is nothing but V in. Therefore, it is equal to V in by R1. But I is equal to IL. Therefore, IL is equal to V in by R1. The output load current is directly proportional to the input voltage. This is the non-inverting mode op-amp, which is acting like a voltage to current converter. Now we are discussing about ground load voltage to current converter. Here we have consciously connected the second end of the load resistor to the ground. That's why it is called as ground load. The current entering here is I1 and the current entering is I2 and the current leaving is I3 or IL. Therefore, I1 plus I2 is equal to IL. From this, I1 is nothing but V in minus VA by R and I2 is nothing but V0 minus VA by R, that is equal to load resistance into, we are taking the current, that is equal to current IL or load voltage by load resistance. Because we want to represent with respect to load current, I am keeping IL as it is. We know already when we are operating the operational amplifier in the non-inverting mode, the gain is 1 plus RF by R1 into V in. Here V in is VA. This is not V in. Whatever the voltage we are applying to the non-inverting terminal, that is the V in. Here V in is VA. Therefore, because we are using the both feedback resistor and the input resistor, both are same, therefore V0 is equal to 2VA. Now we are substituting V0 is equal to 2VA, then this equation is becoming V in minus VA by R, 2VA minus VA, this is equal to VA by R. So this plus VA by R and this minus VA by R will be cancelled. Finally we get V in by R is equal to IL. The output current is absolutely depending on the input voltage, that's why it is called as voltage to current converter, where we use this circuit in voltmeters, analog meters, analog voltmeters, where our deflection needle, we expect when we are changing the voltage, the needle current should change. The needle gets deflected because of the magnetic field effect. When the current is observed in the needle will be deflected. If more current is observed, the needle deflection will be more. So we are converting the change in the input voltage to the change in the output current. And similarly, when we want to test our LED or any diode or GNR diodes, we use the voltage to current converters. The concept is simple. We are trying to understand what is the change in the output current with respect to the change in the input voltage. If the input voltage is changing, we are expecting output current should change. Then that type of circuit is called as voltage to current converter. If the input current changes and the output voltage changes accordingly, that type of circuit is called as current to voltage converter. That we will discuss in the next class.